Now, these 6 men and 4 women are invited, and each person is likely to participate with probability 0.6 independent of each other. Now, let's just say X1 is the number of men and X2 is the number of women that were present. Okay, so we are not talking about the observation at this point. So let's just model this experiment. You are inviting 6 men, and each man here is likely to participate with 0.6 probability. Therefore, X1, which is the number of men who participates, is going to be a binomial random variable with size parameter 6 and success probability 0.6. And X2 is the number of women who are present or who are going to participate, which is going to be a binomial random variable with size parameter 4, because we have invited only 4 women, and the success probability for any woman to come to the party is 0.6. Again, both X1 and X2 are random variables with this different size parameters here, but same success probability. We know that X1 plus X2, which is X, is the total number of people who are going to participate, which is a binomial random variable with size parameter being equal to 10 and success probability 0.6. Now, we have done this because X1 and X2 have a common success probability. Their success probability are the same. And they are independent because each people are independent from each other. Now, the question tells me X, the total number of people were present, was equal to 7. X1 plus X2 was equal to 7. The question is asking me what? Given that X is equal to 7, or X1 plus X2 is 7, what is the probability of the number of women participated is equal to 4? Or in other words, given that X1 plus X2 is equal to 7, what is the probability of X2 is equal to 4? So the question is asking me this conditional probability. It gives me a partial information. It says that the total number of participation is 7, which is X1 plus X2, but we do not know how many women or how many men were there. What was the probability of all 4 women were present there, which is the probability of X2 being equal to 4. Now, we have that conditional probability. The rest is what? The rest is easy. The rest is requiring us to do the tricks that we have done earlier. So if you have a conditional probability like this, you write a ratio, and in the numerator, you write the probability of the intersection of these 2 events, which is X2 equal to 4, and at the same time, X1 plus X2 is equal to 7. And in the denominator, you write the probability. So let me expand this a little. In the denominator, you write the probability of X1 plus X2 being equal to 7, the conditioning event. So the conditioning event is written as the probability in the denominator. Now, what is the probability of X1 plus X2 to be equal to 7? It is simply the probability of X being equal to 7, right? So for a binomial random variable, the probability of it to be equal to 7. And how about the numerator? So the intersection of X2 being equal to 4 and sum of these 2 random variables to be equal to 7 is the same as X2 being equal to 4 and X1 to be equal to 3, right? So if X2 is equal to 4, then X1 is supposed to be equal to 3 to satisfy this summation. And we know that the number of men and the number of women that has participated are independent random variables from each other. Therefore, I can write these 2 probabilities, the joint probability, as the product of the individual probabilities of probability of X2 being equal to 4 and X1 being equal to 3. Why? Because X1 and X2 are independent. Everybody is independent from each other.